Let me see. The first, I want to talk about like your weekly quiz and the web assign or something like that. Do you remember that we have the two important due days of quizzes and the homework assignment? Do you remember the two due days? Could you write answer on the chatting board? Do you remember? Yeah, so we have the two important days, the Friday and Monday. Thank you. Thank you. Yeah, the Friday and Monday. So you have to finish two kind of things. The first, did you see weekly? I check the middle week quiz. The middle week quiz, you need to finish it on this Friday. The one more self-assessment quiz, same thing. Due date is this Friday. So we have two more web assigned homework. The due date is next Monday. The last one, weekly quiz, is the next Monday. We have two important due days. You always like check these kind of things. The one more, you can find these all kind of quizzes on Canvas. You can go to Canvas. You can click like module. You can click module. So you can go into week one. The week one. So you can find the all kinds of quizzes like homework assignment, everything, and my lecture note. So one more thing, I will like give my lecture section 6.1 today. You can find my lecture note on Canvas, same. You can go into module, you can click week one. The last part has like my lecture note, section 6.1, the same thing. Kasia will like upload her lecture note on Canvas, same. The week one, you can find all lecture note. So one more thing, so could you turn off your audio, please? So could you turn off your audio? So you can check it, your like tab on the Zoom. You can find, you can turn off your Zoom. Sometimes the very noisy to other guys me, so it's not easy to give a lecture. So could you turn off your audio? Yeah, could you turn off your audio? Yep. So one more. So this is like exactly the classroom. The classroom. So we can meet every week on Tuesday with me, Wednesday with Kasha. You can come to this live session. We have to interact together. So if you have any question during my lecture, always ask a question on the chatting board. If you write your question on the chatting board, I will answer your question. One more, I have some question. I want to interact together with you guys. So I just want to ask some question, the same. You can answer from my question on the chatting board. The always use like a chatting board or write. Okay, this is like the basic stuff. So one more. So if you have any trouble, any question in the quizzes, homeworks, some like lecture note, everything, you always use like a discussion board on Canvas. So if you write your question on the discussion board, Kasha and I will help you. So sometimes I just only write the answer from your question. So sometimes we need to make like a video and upload on the discussion board. You can find all kind of answers. So the one more, if you need like office hour, something like that, just send the email to me and the Kasha. So we can meet same the Zoom at the time. I can help you guys. This is one possible. The one more, if you give some like office hours, the first could you like send your question to me like before the like office hour? I just a little bit easier to deal with this kind of things. So this is the whole kind of things in the online class. So now I want to give my lectures to you. The one more, could you turn off your audio, please? Could you turn off your audio? So some students didn't off some like audio. Could you turn off your audio? So this is like better. Some guys said email through Canvas or Office the 365. Either one is fine. Either one is fine. But the Canvas is like good. Either one is fine. No problem. I can get any email from the both of them, Canvas and the Office 365. It doesn't matter. Okay. Now we can start like the section 6.1 together today. Let me see. Okay, could you see my slides, section 6.1, inverse function? Could you see? If you see this kind of things, please answer on the chatting board, please. Okay, good. Good. It's good. Okay, so I'm gonna start like section 6.1. The section 6.1 is like inverse function. So I'm gonna follow these steps. The first, I'm gonna talk about the definition of a function. Second one, definition of a one-to-one function. Third one, the definition of the inverse function. The first one, how can you check if a function has the inverse function or not? Oh yeah, this video is recorded. I upload this like lecture note on YouTube and just upload on Canvas today night. So you can watch this like the recorded lecture again. It's possible. You're right. Yes, I can record and then I just upload. Yes. The fifth one is I just saw only how to find the inverse function. Sixth one, how can you find the derivative of the inverse function? Yeah, this is like whole things. The one more request is could you like turn off your audio and your video? Could you turn off your audio, your video? Please, could you turn off your audio, your video? Okay. Some students said how long does this lecture section will be? Depending on what kind of section do I deal with. Usually 1 hour. Sometimes 1 hour 30 minutes. Sometimes 40 minutes. Something like depending on. But usually 1 hour. 1 hour 30 minutes. This is like the exact time of this lecture. So this is the definition of a function. Would you like the definition? A function f from set A to set B is a relation that assigns to each element x in A exactly one element y in B. This is like a definition. So we have two important keywords here. What's that? Here. Each element x in A. The second important thing is exactly one element y in B. So we have two important terminologies of the function. Let me see. The A is called the domain of F. B, the codomain of F. F of A. So what's like f of x, f of A? The collection of function value f of x such that x is in domain A. The range of f. So this is like one example. So this one is a function or not? What do you think? This is a function or not? Could you write your answer? This is a function. Yes. This is not a function. Answer is no. So what's your answer? So could you write your answer on the chatting board? Okay. Okay. Good. Most of the students said yes. Right. You're right. Why? I can check definition. Each element, you can choose only one element, one. Each element, one, is going to exactly one element, four. You choose two, two is going to exactly one element, six. Choose three, three is going to exactly one element, five. Yes, this is a function. What's the domain? Could you write domain on your chatting board? What is the domain? Could you write your answer? Okay, good. The most of the students said yes. 1, 2, 3. Exactly. Set A. The set A was a codomain. The same. Could you write your answer? Okay. Now we have two kinds of answers right now. The 4, 5, 6 is one answer. The other answer is 4, 5, 6, 7. So 4, 5, 6, 7. Whole B is exactly codomain. What is 4, 5, 6? The 4, 5, 6 exactly the collection of function values range, just like range. The range is 4, 5, 6. The 4, 5, 6 is the range of F. The next one, you can check this is a function or not. What do you think? This one is a function or not? So yes or no? No, no. This is like the same request. Please turn off your audio. Please turn off your audio. This is like better for interact with you. Most of the guys write no. Only 3 or 4 the students said yes. So let me see. We are going back to definition. What's that? Each element is going to exactly one element. This is function here. 1 is going to exactly one element, 5. 2 is going to exactly one element, 6. The 3 is going to exactly one element, 5. It doesn't matter. Two different numbers in the domain are going to one number in the codomain. There's no problem. This is function. This is a function. What's the domain? 1, 2, 3. The same. What is codomain? What's codomain? Yes, codomain is whole part B. This is always codomain. The 4, 5, 6, 7. What is range? Only assigned number 5 and 6. We have two numbers exactly, range. Codomain is different from range. It's range. Here, this is a function or not. Okay. Thank you for your answers. Not a function because 1 is going to 2 numbers, not exactly 1 number. Here, this is not a function. So in this case, function f is not a function. You don't need find domain. You don't need to find codomain. You don't need to find range because f is not a function. You don't. Definition of one-to-one function. A function f is called one-to-one function if it never takes on the same value twice. That is, f of x1 is not equal to f of x2 whenever x1 is not equal to x2. Let me see. This is example. Please turn off your audio and videos, please. Sometimes the very noisy things. Please turn off your audio, please. Yes, this is one-to-one. Could you write your answer? This is like one-to-one or not? Okay, thank you. Your answer is right. This is one-to-one because f never takes on the same value twice. So what does it mean? The 1 is going to 4, 2 is going to different number 6, the 3 is going to different number 5. So this is one-to-one. What's that? This is one-to-one or not? Yeah, this is not a one-to-one. Because f takes on the same value twice. What does it mean? 1 is going to 5, the 3 is going to 5. So f takes on the same value twice. This is not one-to-one. Please turn off your audio. Please turn off your audio. Turn off your audio and your video. Please turn off your audio and video. So next one. Horizontal line test. Was it like a horizontal line test? This is geometric method for checking if the function is one-to-one or not. A function f is one-to-one function if and only if no horizontal line intersects its graph more than once. This is the definition. Here. So what's that? This is one-to-one or not. The function f is this one. This is one-to-one or not. Okay, could you write your answer on the chatting board? Good. Thank you for your answer. This is another one-to-one. Because here, Its value is, I can write y1. What does it mean? x1 is going to y1. x2 is going to same number y1. The function f takes same value on the same value twice. This is not one-to-one, not one-to-one. So here, f of x equals x squared. This is a one-to-one or not. The same question. X squared is not one-to-one or one-to-one. Okay, thank you all of guys. So was it like a graph? The f of x is parabola. So we have graph is like this. You can draw horizontal line. What does it mean? We have two intersection points. To violate this condition, not one-to-one. It is not one-to-one. What happens? G of x. G of x is one-to-one or not? Yes or no? So could you write your answer? Okay. Thank you, all of guys. Answer is yes, because the graph of g of x is like this one. You can draw horizontal line. We have only one intersection point. The g of x is one-to-one. One-to-one. That's it. This is the idea by using horizontal line testing, like this. The next one. Definition of inverse function. The function f is one-to-one. So we can define the inverse function of f. The domain A, range B. The inverse function is like this, f to the negative 1. It's like a notation of inverse function. Has a domain B. The range is going to domain, is right? The function f has range B. The domain of B is exactly the domain of inverse function. The range is A. Just to interchange domain and range. Just like idea. So what's like the inverse of f of y equal to x? Exactly same to f of x equal to y. This is like the definition of inverse. This is one good diagram. Here, x is going to y function of y is going back to x inverse function, right? In this case, we have one theorem. Function f is one-to-one. The inverse of f exists. Inverse function exists. What's like a domain of inverse? Domain of inverse is here, P. Same to range of f. The range of f. Similarly, range of inverse function is A. Same to domain of f. Only interchange domain and range. This is like idea of inverse function. The one more. What's the inverse of x? Is it not equal to 1 over f of x? Don't use. Totally different. This -1 is not a power. Not a power. Don't use. No. The cancellation equation. We have one property from the one-to-one function and the original function, Inverse of f of x equals x. For every x in A, inverse of f of x equals x for every x in B. So we have cancellation equations. I know some like this, the same things. Please the turn off your like audio and the video, the please. The sometimes the your like voice is coming out. The some guys, some students, the cannot catch my lecture. The please, the turn off the your audio and the video on Zoom. You can find some kind of like the things on the Zoom. The could you turn off your video, your audio, please. The next one here. I want to check. This is one-to-one ONR. Yeah, thank you, Jackie. Yes, you can only like mute. You're right. Yes. Yep. This is like one-to-one. Yeah, you answered yes. Okay, good. Okay. Okay, the same. The another students come this session right now. Please turn off your audio, turn off your video. You can change mood on your audio. Thank you. Could you turn off your audio? Yeah, the most of guys said like yes, you're right. This is one-to-one function. One-to-one function has inverse function. What's it like inverse function? Opposite way. 4 is going back to 1. 6 is going back to 2. The 5 is going back to 3. Exactly this one. It's like inverse function on the right-hand side. Here, so we have one good result if f is one-to-one, inverse f exists. So you're right. The function f never takes on the same value twice, always one-to-one. You're right. Yes. This one is 1 is going to only number 4. The 2 is going to 6, 3 is going to different number 5. But 1 is going to 4, the 2 is going to 4, not one-to-one. Not one-to-one. Yeah, this meaning, not one-to-one. Yes. So you can draw horizontal line. We have only one intersection point. This is one-to-one. We have three intersection points, not one-to-one. So here, was it like A? A is domain of F, the same to range of inverse, is right? This A is domain of F, also same to range of inverse function. Was it like B? The range of F. This is range of F, also domain of inverse function. The one more, cancellation equation works or not. You can calculate inverse of f of 1. What is f of 1? Could you run your answer? What's f of 1? So this, you're right. The 1 is going to 4. You're right. Yes. 4 like this. Next, what is inverse of f of 4? Good. The 4 is going to 1. Yes. Like this. What happens? We have one good result. Inverse of f of 1 is exactly 1. What does it mean? Cancelled. We call cancellation equation. So like this. So this is true. The cancellation equation works. The inverse of f of the inverse of f of 4 is similar result. Inverse f of 4 is here. 4 is going to 1, f of 1. What's f of 1? The 1 is going to 4, we have 4. So what happens? Cancelled. We have cancellation equation works. Yep, the inverse meaning is you're right. Switch x and y value is right. Yes. Was it like inverse function? Function f of x is given, y equals f of x. Yes. You only interchange x and y. This is the key part. Key part for finding inverse function. Good point. Thank you, James. So next, what do you think? This is a one-to-one or not? Yeah, please turn off your audio. Please turn off your audio. This is not one-to-one because f takes on the same value twice. The 1 is going to 4, 2 is going to same value 4, not one-to-one. So this can use inverse relation. What's inverse relation? 4 is going back to 1, 4 is going back to 2. This is a function 1. The inverse relation is a function 1. What do you think? Yeah, the not a function. The one number is going to two numbers, not a function. What does it mean? Inverse function does not exist. This is like a key here. We had one good remark. Function f is not one-to-one. What's the conclusion? Inverse function does not exist. Does not exist. This is like idea. This is idea. The next one, how can you find the inverse function of f? So we have a algebraic method and geometric method. What's it like algebraic method? Step 1, write y equals f of x. Step 2, solve this equation for x in terms of y. Step 3, interchange x and y. The resulting equation is y equals inverse of f of x. So that's it. This is algebraic method. Was it like a geometric method? The graph of inverse of f is obtained by reflecting the graph of f about the line y equals x. So what does it mean? This meaning is, was it like the geometric meaning? Exactly. Interchange x and y. It's like exact meaning. It's like a key part. Interchanging x and y. It's like exact geometric meaning. This is like inverse function. Do you know? So my question, inverse function exists or not from this example? What do you think? Inverse function exists or not? Okay. A lot of students said no. Your answers are right. So because I want to use horizontal line test. You can draw graph x squared plus 1. X squared plus 1 is, this y-intercept is 1, only passing through y-intercept 1 like a parabola. I want to draw horizontal line. We have two intersection points. What does it mean? Not one-to-one. Not one-to-one. So what happens? Inverse function does not exist. So that's it. This is answer. You don't define the inverse function. So like this. Next one. Inverse function exists or not? What do you think? Okay. Good. Inverse function exists. This graph. We use this domain. X is less than y equal to 0, only left-hand side. This is like f of x. You can draw horizontal line. We have only one intersection point. Yes, this function is 1-to-1. Inverse function exists. How can you find? I know follow 3 steps from the algebraic method. You can write y equals f of x. So we have y equals x squared plus 1. Step 2, solve this equation for x. No. So the James asked this question. Do we have to graph to be able to tell like inverse function exists or not? No, you don't need it. So you don't need to draw. The only think about the function is given like this. So only algebraically, no problem. Depending on your choice, you don't need. But graph is sometimes very helpful for checking the one-to-one function or not. This is like a reason we can draw the graph. So yeah. Step 2, solve this equation for x. Algebraically, how can you tell if the function is one-to-one or not algebraically? So algebraically is like this. So I will answer your question. One example is the f of x equals x squared plus 1 is given. So this is like a one-to-one or not. This is like even power. So what happens? You can plug 1. The 1 squared plus 1 is like 2. You can calculate f of minus 1. The negative 1 squared plus 1 equals also 2. What does it mean? 1 and minus 1 are going to same number 2. F takes on the same value twice, not 1-to-1. Like some algebraic way, is it possible like this? But geometric method is, I think, a little bit easier in this problem. The geometric method is a little bit easier. So we are going back to step 2 again. So how can you solve this kind of things? So you can solve this equation for x in terms of y. So you can write y equals x squared minus 1 plus 1. Subtract 1 from both sides. We have this result. X squared equals y minus 1. Next here, you solve. What is x? This is right. This is right or not? What do you think? So my answer is the right answer. X equals square root of y minus 1. This is right. Yes. The 1 student should know. The 2 students should know. 3 students should know. The 4 students should know. 5, 6, okay. Let me see. I'm gonna give you one more example. To really be careful. You're right. Both positive and negative. Just really be careful. One example is x squared equals 4. What is x? What is x? Yes, plus minus 2. So really be careful. This is like even power. We have 2 possible answers. Positive root y minus 1, negative root y minus 1. So James said you can decide positive or negative in step 3. Here, in step 2, so we have 2 possible answers like this. So my question, which one is right answer? Positive 1 or negative 1? Which one? So you said positive or negative? Which one? Negative 1 or positive 1? Negative, okay. Negative, okay. negative, positive, negative, negative. So negative. Why? Use domain. Domain is x is less than y equal to 0. X is negative number. Here, x is negative number. Don't choose this one because domain x is less than y equal to 0. This is the reason, depending on the domain. How can you choose the exact answer? Always, depending on the domain. Depending on the domain. So we have it like this because x is less than or equal to 0. The step 3. What's step 3? Interchange x and y. So what does it mean? So you have to only interchange x and y. To replace x by y. To replace y by x. So that's it. This function is inverse function. This is answer of this question. So how can you find inverse function by using graph? So do you remember? So how can you do that? You can draw y equals x. You can draw y equals x, dotted line. The f of x is this black one. So this one is f of x. How can you find inverse function? Just reflect the graph of f about y equals x. So this one is going to this one here. Graph is like this. This is inverse function. So what happens? Function f of x inverse function is symmetric about y equals x. Symmetric about y equals x. That's it. This is like a geometric method. So like this. So we have it. This red one is exactly inverse of f. This is like a whole idea for solving this problem. Next here. Okay. I just wait the question. What is your question? We should repeat. You said the geometric method again? Sure. I want to explain geometric method again. Would you like a geometric method for finding inverse function? This is the idea. The graph of inverse function is obtained by the reflecting the graph of f about y equals x. So what does it mean? You can draw y equals x here. You have to reflect this graph, the black one, y equals x about y equals x. Only reflect here. Only reflect. That's it. So what happens? This black one and red one is symmetric about y equals x. That's it. This is the whole idea. It's good? This is like the main idea for finding inverse function geometrically. Yeah. So we are going to next one. The derivative of inverse function. How can you find the derivative of the inverse function? So we have one important theorem. So if function f is a one-to-one differentiable function, with the inverse function is f to the minus 1, just notation. Inverse, the f prime of inverse of f of a is not equal to 0. Then the inverse function is differentiable at a. So how can you find? You have to memorize this theorem. This is very useful and important part in section 6.1. 1 over f prime of inverse of f of a, right? So how can you prove? The y equals inverse of f of x is given. You can change it to the definition. X equals f of y. Remember this definition? So what does it mean? You can draw diagram. This relation is very clear. This is like a domain. This is like a range. We have x is here. This is like y. X is going to y. So we call inverse function. The inverse function. What happens? Going backward. Y is going to x, f. So we have x equals f of y. What does it mean? Interchange domain and range. Interchange domain and range. We have function f from the inverse function. This is like one good relation. Next, differentiate x equals f of y with respect to x. So like this, take derivative. So what is x prime? What is x prime? Could you write your answer on the chatting board, please? What is x prime? Do you remember? You just only remind the math 140 was like x prime. What do you think? Is it 1? 1 is right. What do you think? 1? Dx is, you can use differential form. Usually we don't use dx. So we can use dx later. So for solving like integral problem, you can use it later. So x prime is 1. You're right. X prime is 1. You're right. 1 equals what is f of y prime? You can use f prime of y times y prime. Yes, dy of dx. You need more, but not dy of dx, because do you remember chain rule? You think about chain rule in math 140. What is f of g of x prime? F of g of x prime is outer function f prime of inner function g of x times g prime of x. So like this. So was it like g of x? G of x is function y. Was it not variable? Exactly. F of y prime is, you can use chain rule. F prime of y times inner function y prime. That's right. We have f prime of y times y prime. The next, you solve this equation for y prime. So what does it mean? Divide the both sides by f prime of y. So what happens? Crossed out. So we have y prime is 1 over f prime of y. So like this. That's right. So we have it. The next, you can replace what is y. What is y? What is y? Yes, inverse function. Here, y is inverse function. You can plug this one into y. Here, plug into y. So what happens? Inverse function of x prime equals 1 over f prime of inverse of x. So like this. You can change the left-hand side a little bit. I want to use another notation. This is same to inverse function prime at x. You can use another notation. So like this. This one. The next, replace x by a. What do you replace x by a? Here, only replace x by a. X by a. So what happens? That's it. We have this result. This is the whole idea, right? Like this. So one more. So when you use this theorem, we have one important condition. Function f is what? One-to-one. Function f is one-to-one. Yes, you can use the theorem. Function f is not one-to-one. Don't use this theorem. Here, the last example. So f of x equals 2x plus cosine of x. Find inverse of f prime of 1. So let me see. Before you use theorem, you can check. Function f is 1-to-1 or not. What do you think? The 2x plus cosine of x is 1-to-1 or not? This is 1-to-1? Yes. Yes. Okay. So most of students write yes on the chatting board. So okay, good. Your answer is right. Your answer is right. It's good. Why? How can you prove? How can you prove and verify that function f is 1-to-1? Do you have any idea? To sketch the graph, you can draw the horizontal line. You can check how many intersection points do we have. We have only one intersection point. Function f is 1-to-1. This is like one idea, but 2x plus cosine of x, not easy to sketch the graph. Now you want to use increasing, decreasing test. Do you remember increasing, decreasing test? This one was like increasing, decreasing test. The f prime positive, function f is increasing. F prime of x is less than 0. The function f is decreasing. We call increasing, decreasing test by using the first derivative. James said you can plug the values into the function so you can check 1-to-1, but in this case not easy because what's like a domain? The x is any real number. It's impossible to plug the any number into f of x. You know, those are not easy by using algebra. So what's like the best way? You can take a derivative. F prime of x. F prime of x is 2x plus cosine of x prime. The 2x prime is only x prime is 1, 2. Do you remember cosine of x prime? What is cosine of x prime? Okay, the 2, yeah, negative sign, right? Negative sign. Okay, good. Oh yeah, negative sine x times x prime. You're right. What's x prime? X prime is 1. So just negative sine x. Yeah, just negative sine x. So we have cosine of x prime is negative sine x. I'm gonna check. 2 minus sine x is positive or negative? Depending on x, what do you think? Always positive? You can plug any number, this is always positive? Yeah, this is always positive because what is range of sine of x? Range of sine of x is between -1 and 1. You can plug minimum value into here, what happens? So 2 minus -1 minimum value plug into sin x is a positive 3. You can plug maximum value into sin x. 2 minus 1 is only 1, like a positive. Minimum is positive, maximum is positive. So any number between minimum and maximum also positive. Yes. You can use increasing, decreasing test. Function f is increasing. Function f is increasing. Increasing on all real numbers. So like this. So what does it mean? I don't know exact graph, but we know graph is what? Just increasing. You can draw horizontal line. We have only one intersection point. So function f is automatically 1 to 1. This is idea for checking 1 to 1. Like this. The next tip, I want to use the conclusion of previous theorem. Inverse of f prime of 1 is 1 over f prime of inverse f of 1. How can you find this one? We always follow 3 steps. Step 1, you can find this inside value. Find this one. Step 2, you can plug this value into here, find whole denominator, f prime of inverse of f of 1. Step 3, you think about reciprocal. Reciprocal is 1 over f prime of inverse of 1. This is the whole idea. So step 1, how can you find inverse of f of 1? So we don't know. We can write x. How can you find x value? I want to use definition of inverse function. Do you remember this one? Inverse function of y equals x equivalent to the y equals f of x. Just interchange x and y. This is like a definition of inverse function. So the same to what? 1 equals f of x. You can change it like this. What's it like f of x? F of x is this original function 2x plus cosine of x. 1 plus. Sorry, I can erase here. One equals f of x is 2x plus cosine of x. So we have it. So how can you find x value? You have to guess. So guess what is x? You can plug some number into x. So what kind of a number satisfies 1 equals 2x plus cosine of x? What is your answer? You can plug some number. So which number has this equation satisfied? Okay, the most of guys are right. 0, you're right. Yes, x equal to 0. Yes, x equal to 0. I want to confirm. You plug 0 into here. What happens? Right hand side, left hand side. 1 equals, right hand side is 2 times 0 plus cosine of 0. The 1 equals 2 times 0 is 0. Cosine of 0 is 1. Yes. The x equal to 0 satisfies this one. What does it mean? This x value equal to 0. Next is step 2. The f inverse of f1 is exactly 0. You can plug this one into here. So we have f prime of 0. We already have f prime of x, 2 minus sine x, you plug 0 into x. You plug 0 into x, 2 minus sine of 0. What is sine of 0? Do you know what is sine of 0? What is sine of 0? Answer is okay, good. Yeah, the most of students said the 0. Yeah, right answer. Yes, 2 minus 0 is 2. This is not a final. What's your final answer? Reciprocal. Just only reciprocal of 2, only flip. This is final answer for solving this kind of problems. It's good. So this is like a 2-day lecture. So if you have any question, please write your question on the chatting board. I can help you. So if you don't have any question, you can leave this live session. Anyway, thank you for attending today class. I'm very happy to work with you guys. Really very. Thank you very much. So any question, yeah, you're welcome. So you can write your question on the chatting board. I will answer your question. Yeah, you're welcome. All of you guys. Yep. Yeah. Have a nice night. Thank you. The one more. The tomorrow, the 9 a.m. Kasha will give a lecture. The section 6.234, the 3 sections. You don't understand the first step? Oh yeah. The first step is the here. This one. So first step is always this number. Inside 1, the always inverse of 1, always write like x. The next, you have to use definition, change 1 equals f of x. It's always the same things. What's like f of x? Here. So 1 equals 1 equals x plus cosine of x. Next, so you have to plug some number into here, which number satisfies this equation. Only guess. The small number is better. So in this case, we have a cosine function. What's like the best way? You can plug 0, pi over 2, pi over 6, pi over 4, pi over 3, the like special angles that satisfies you whatnot. That's like the best way. So you plug 0 into here. The 1 equals 0 plus cosine of 0. Exactly. The cosine of 0 is 1. That satisfies. So we have x equal to 0. The x equal to 0 is exactly same to inverse of f of 1. Right? Plug into here and calculate. Just like whole idea. Does it make sense? So what do you think? The even number equation textbook? I don't think so. Only odd number things. We have only odd numbers. So this is very helpful. Only to try to solve like odd number problems. Very helpful. So for understanding this kind of concept, and you can prepare for your like quizzes at the exam. Very sufficient, I think. But we don't have it. So sorry, we don't have a solution of even numbers question that suggests the problem. Only odd numbers. You can try to solve only odd numbers. These are live sessions. You can either finish this kind of things, no more live sessions. As I said before, if you need some more question, we can meet this Zoom again. Just only make an appointment. You can send the email to me. What time is good for you? What's your question? We can meet this kind of things at the same time. I'm gonna explain these kind of things is possible. You're right. So the question is the inverse of any number equal to, you're right, yes, always x, and the solve for x, you're right, yes, solve for x. Yeah, solve for x, you're right. Not all the time. We have only live session is like this one, the 7:30 p.m. On Monday, the 9 a.m. Not Monday, the 7:30 p.m. Tuesday, with me, I will cover the one section. So the Kasha covers other sections in week one, like on Wednesday. We have one more live session from the what's that the guided study group leader. He will give a live session maybe the Thursday or Friday. Is not set up right now. I'll just let you know that he set up the exact live session. We have the three times every week, me, Kasha, and the guided study group leader. So we have 3 live sessions. So one more thing is, if you need more help, always send the email. So we can meet this kind of Zoom again. I can help you like office hours. It's possible. Okay. So thank you for attending today's class. So I just want to upload this lecture video on Canvas. If you want to watch it again, please watch again. And the any question, let me know later. Yeah. Okay, you're welcome. Yeah, I upload this lecture video on Canvas tonight, around 10 p.m. to 11 p.m. Yeah. Yeah, bye-bye.
Bye.
Bye-bye.